Ngayon dito tayo sa second floor level. So as I've said before, kalahati ng columns, bubuhatin niya, kalahati ng column sa ilalim, bubuhatin niya ulit, tapos yung beams, so that is the self-weight, and then the superimposed dead loads, you have the walls, you have the floors, and then you have the stairs. So basically, same procedure, but different dimensions, different weights. So for the square columns, you have the properties. You have R8 and R9 sa ilalim. So R8 is 0.4, R9 is 0.43. Ayan. So 0.4 and then sa ilalim 0.43. The length is 3.2 divided by 2. And then you have the weight. That is equal to the volume of concrete multiplied by the density. Ganon din sa square column sa ilalim. This is 0.43, so I get 83.64. For the second floor beams, nagkataon na lahat sila ay R4 except dito sa grid 3, which is R11. So let's start with the longitudinal beams na 4.5. So, ito siya, no? 4.5, tatlo. Again, you have another 4.5 here, tatlo ulit. So, all in all, we have 9 units na 4.5 meter beam na R4 ang section. So, that is 35 by 0.45. 9 units, length 4.5, that is R4. And then, dito naman sa 7 meter, that is at grades 1, 2, and 4. So, that is 3 units na 7 meters. Still the same section. Tapos, dito naman sa 2.5, you have 4 na R4. Ayan, 4. Okay? And finally, sa grid 3, ang naiba, you have reference 11 or section 11. It is 380 by 530. Ito yun. So, 380 by 530. And you only have 1 unit. So, you get the volume, multiply it by the density. And you have a total of 298.55. Now, let's go to the superimposed dead loads. Okay, first you have the exterior wall. Parehas lang sila nung third floor. So 27.5. Pati rin sa interior wall, parehas din, 23. But this time, the railing is different. Ang railing natin dito lang sa labas, wala sa loob kasi stairwell pareho pababa tsaka pataas. So, that is equal to 4.5 times 3 plus 2.5 plus 2.5. That's how you get your 18.5. Okay, so next is we now multiply the height times 2.98 times the total length. Okay? And then you add them all, you get 502.577. Next is floors. This time you have 2 slabs lang, number 1 and slab number 2. Galing ulit ito dun sa computation ng staad. Okay, so area you have 9 times 7 and then 2.5 times 13.5. And you have a total of 501. Ngayon, ng stairs natin, the load from the staad, you have 15.8644. And it is applied over the entire length. Yung stairwell going down, tsaka yung stairwell going up. And fortunately, parehas sila ng stair height, kaya parehas lang silang 15.8644. So, the length covers the entire 4.5 meters. And then, yung kanyang railing, meron tayong railing pataas, yung galing sa third floor, that is 5.96. So, you simply multiply this by 2 since meron ka ring railing pababa. Okay, kaya siya naging 11.92. So, that is 2 times 5.96. And for that stair load, you add them, you have 83.3096. And then you add all this, stairs, plus floors, plus walls, plus lower square columns, plus the beams, plus the upper square columns, and you get 1542.19. Ito yung manual, and then ito yung kay STAAD. Notice na decimal places lang ang kanilang pinagkaiba. Finally, dito na tayo ngayon sa first floor level. Bakit ako naglagay ng computation ng weights sa first floor? Ka-level naman na niya yung tabon, yung lupa. Dahil, naglagay ako ng weights dyan kasi meron tayong tie beam na nilagay dyan. Okay? Kung yung beams na yan nasa tapat ng footings, hindi na tie beam ang tawag doon. Strap beam ang tawag doon. Okay, so ang bubuhatin ngayon ng first floor beams, you have the weights but not the slabs. Dahil yung slab, it is poured directly over the fill. Kaya yung floor load ng slab matratransmit yan sa lupa. That's why hindi ko na isinali yung slabs dito. Okay, so yung bubuhatin ngayon ni 1F beams is kalahati na naman nung columns sa taas, tsaka yung kalahati nung columns sa ilalim, which is 1.5 divided by 2. Okay, so the section of the columns you have R9 and R10. Okay, so that is 0.43 and 0.43. So parehas lang silang section. Obviously, kailangan magparehas yan kasi parang isang column ang dating yan. Okay? Pero in reality, dalawang columns yan kasi separated sila by beams. So this is 0.43 and then 0.43. Then the length is story height divided by 2. Ayan, 3.2 divided by 2. Tapos, dito naman, kay footing columns, you have 1.5 divided by 2. So they are both 12 units and meron na tayong computation ng kanyang loads. And then sa first floor beams naman, so ito siya. First floor beams. Lahat sila ay R6 except yung nasa grid A prime na R5. Okay? So, dito nakapatong yung ating stairs. So, remember na dito sa R5, meron pa ring nakapatong na stair load tsaka railing. Don't forget that. That is part of the superimposed dead loads and the walls. So, let's go back to our beams. So, meron tayong 9 units na 4.5. Ito. At this grid, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And the length is 4.5. R6 is 0.35 by 0.48. Okay, ito siya. Tapos, dito naman sa transverse beams, you have 7 meter length. Apat ulit yan. 1, 2, 3, 4. Okay? And meron din tayo dito na 2.5. Apat din siya. Bakit hindi na lang natin ginawang 9.5 yan? Pwede, pero take note na meron tayong separator dito na column. Yan. So, para hindi tayo mawala, ihiwalay na lang natin. Next question. Etong are at this grid, ba't natin hindi pinaghiwalay? Kasi, walang column dyan kahit na meron siyang separator na beam. Okay? So, take note na ang length natin is separated by columns. Next, we have here the R5. The length is 4.5 meters and the section of R5 is 0.3 by 0.45. Ito yan. So, you multiply the volume, total volume multiplied by the density and you get these weights. You add them, you have a 325.04 kilonewton for 1F beams. And then we have the exterior wall. This time, since it is on level ground or on the ground, kailangan mo ng mas makapal na wall, de 5. Okay? Dati nga, de 6 ang nilalagay namin sa first floor. Pagdating na sa second floor, de 5, pero ngayon de 4 na lang. Pero kapag first floor, definitely hindi pwede ang de 4 na hollow blocks sa exterior wall. So the total length of the exterior wall, we have this, and then yan, 7 meters. Tapos ito, and then still part of the exterior wall, ito siya. Tsaka syempre lagyan din natin dito sa harapan. Yan. And finally, yung interior wall dito lang sa between the two rooms, that is 7 meters. Now, the total length you have 4.5 times 5 plus tatlong 7. That's how I got 43.5. Okay, the height is 2.9. That is 3.2 minus 0.3 again. Ngayon, yung weight niya, the unit weight of the wall is 3.0455. That is taken as 2.565 plus both face plastered. Ito naman, de 4 lang yan. 2.98. 2.5 plus both face plastered. Next, you simply multiply the area, which is the total length times height times the load. That's how you get your values, 384 and your 60. You add them and you get 444. And then finally, for the stairs, you have the stair slab tsaka yung railing. Again, you have 15.8644. This is taken from stud. Yung railing, 5.96 concentrated. That is taken again from stud. Now we add them all. You have the stairs plus the walls plus the columns sa ilalim plus the beams plus columns sa taas. And you get 934.174. Okay? So, yaan ang sa first floor. Ito naman yung computation ni STAAD. So, all in all, we have the seismic mass. Ngayon, yung seismic mass na yan, i-add lang natin yung mga na-compute natin. So, this is the first floor plus the second floor plus the third floor, and finally the roof beams level. Okay, so yan yung ating seismic mass. Pero, take note na yung kinompute natin na seismic mass ay hindi kasama yung kalahati ng footing columns. Ito lang yun. Okay? Yan. So, if you will add the footing columns, then you have the complete seismic mass. Okay? So, yan. May comment dito na whole footing column. So, you simply add again the weight of the lower half of the footing columns, which happens to be, na-compute na natin dito, 39.208 plus yung seismic mass na na-compute natin, and you will get 4522.815. Yan yung seismic mass nung entire structure, which is 4522.815. Ito rin yung i-compare natin kay STAAD. Ang na-compute ni STAAD is 4522.86. So again, very minimal lang ang kanilang difference. Now, I want to show you the output from STAAD. Pasado na yan sa design of beams and columns. Yan yung ginamit ko sa seismic computation ng loads. Okay? So, sa editor, dito tayo sa my command file. Immediately after dito sa loads, okay, sa reference loads, i-edit natin yung floor diaphragm. Okay? Take note na sa STAAD, hanggang ganyan lang yan. Yung diaphragm natin, nasa first floor, second floor, and third floor. Dahil yan lang yung may floors, obviously. Pero, para makompute natin yung seismic weight at the roof deck, isasali natin siya. So, for now, ganito yung sa pag-design ng concrete, beams, and columns, hindi natin isasali yung roof deck kasi hindi natin isasali yung walang rigid floor yung roof level. Kasi yun naman ang actual structure. So, let me show you. So, we analyze. And then, output file. Tapos, sa floor, i-click mo tong floor diaphragm. Okay? So, lalabas dyan yung ito. Alright? Now, punta tayo ngayon sa dito sa scroll down mo lang yan. Oops. Wait. I-edit ko lang yung aking command file. Dito sa perform analysis, nalagay ko kasi ng print all yan. Ganyan lang, no? Perform analysis, and then that's it. Tapos, pakita ko yung aking diaphragm. Tatlo lang, no? Then, I will show you now the output. Ay, mag-work ka. Yan. So, i-click natin yung floor diaphragm. Yan. So, ito yung seismic weights. Tapos, dito sa soft story check. Ayan. Just under the soft story check, lalabas dyan yung base shear. So, we have here the time period 0.445 and 0.847. Tapos, meron dito yung load factor na 1. Saan galing tong 1? Remember na nag-set tayo ng dun sa seismic X. Ayan yun, no? And then, ang ating code is UBC 97. Tapos, ito yung seismic weight na 4522.86. Ito yung kanyang base shear. Okay, so balik tayo. We first compare this with our weights. Okay. So, yan yung seismic mass 4522.815 kay STAAD 4522.86. So, ibig sabihin, tama yung ating manual computation. Tapos, yung base shear niya 585.31. Ang computation naman natin is 585.31. Anyway, but this will be our next topic. Okay, so let's go back to the floor diaphragm. Click natin yan. Ito ngayon yung weights. We compare this with our Excel. At first floor level or at roof beam level, you have at roof beam level you have 434.79, pero dito wala kasi hindi natin sinet na diaphragm si roof beam, no? Now punta tayo kay third floor level, which is at 7.9 meters. So, ang na-compute natin is 1572. Ayan siya, 1572. Tapos, ito yung floor level, 7.9 meters. So, parehas tayo, no? With this STAAD. And then, at second floor level, the height is 4.7. Kay STAAD, you have 1542.21. Sa manual, you have 1542.19. So, parehas pa rin. Hindi nagkalayo. And finally, at first floor level, at 1.5 meters above the top of footing, you have 934.17. Yan. Next, paano natin ma-check yung seismic mass? Tsaka isali natin yung roof deck. Yan ang tanong ngayon. So, i-edit natin yung command file. I-add natin yung roof level as rigid diaphragm. So, diaphragm number 4 is, the type is rigid, the height is 11.1. So, we will now save and then we will analyze again. Tapos, dito tayo sa floor diaphragm. Yan. So, lumabas na ngayon si roof level. Yan. 11 at height 11.1, 434.76. So, let's compare that with our roof. Ayan, 434.79 sa manual, dito 434.76. So, correct siya. And then, how do you compare the total seismic mass? yung 45 to 2.815. As I've said before, dito yan sa soft story check. Just sa ilalim niya. Ayan siya, 45 to 2.86. Another check for the seismic mass of the hull, ano? Dito mo siya titingnan sa post-processing. Okay mo lang yan. Tapos dito sa reactions. And then dito sa load case number 3. Dito sa FY. Yan. So load case number 3, that is the dead. Load case 1 is seismic. Load case 2 is seismic. Load case 3 is dead. Dito yan sa column FY. Ayan. 4522.859. Sa manual, 4522.82 something. Okay guys, so hindi tayo ganong nagkakalayo with STAAD. So our next topic would be computation ng base shear. So, ito, meron din sa STAAD nito. So, solvein natin to mano-mano next time. But, let me show you. Ito yung na-compute. Gagamitin nating seismic mass. We will include the half of the footing columns. Dapat buo. Okay? Ayan. Seismic mass, full footing column, 4522.815. And then, ang base shear nung building, okay, from this equation 208-8 is 857.99. Pero masyadong malaki ito. Dito lang tayo. Okay, so this will be our next topic. As you can see, kay STAAD, ganyan din ang kanyang computation. Ayan, 585.31. I will show you how it is done manually. Okay guys, thank you for listening.